Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Imagine a huge factory fan running at full speed, even when the plant needs only half the airflow. Imagine a pump pushing water at maximum power, and then the operator reduces flow by partly closing a valve. The motor is still working hard. The electricity meter is still spinning. Energy is being wasted as heat, noise, vibration, pressure loss, and unnecessary mechanical stress. Now imagine one device quietly controlling the speed of that motor like an accelerator pedal controls a car. That device is called a VFD, variable frequency drive. A VFD does not just start and stop a motor, it controls how fast the motor rotates. And in industries where motors run pumps, fans, compressors, blowers, conveyors, mixers, cooling towers, and HVAC systems, that control can save a massive amount of electricity. Electric motor-driven systems are one of the largest electricity users in the world. The International Energy Agency has reported that motor-driven systems account for more than 40% of global electricity consumption. So when we talk about VFDs, we are not talking about a small electrical accessory. We are talking about one of the most powerful tools for industrial energy efficiency. Part 1. A short history of motor speed control. Before VFDs became common, controlling motor speed was not easy. In the early industrial age, factories used steam engines, belts, pulleys, gearboxes, and mechanical clutches to control machine speed. If a machine needed to run slower, engineers often changed pulley size or gearbox ratio. Later, with the growth of electric motors, factories gained cleaner and more reliable power. But there was one problem. The standard AC induction motor was strong, simple, and rugged, but its speed was almost fixed. The speed of an AC motor depends mainly on two things: the supply frequency and the number of poles in the motor. In India and many other countries, the power supply frequency is 50 Hz. In the United States, it is commonly 60 Hz. For a 4-pole induction motor on a 50 Hz supply, the synchronous speed is speed equals 120 times frequency divided by number of poles. So, speed equals 120 times 50 divided by 4 equals 1,500 revolutions per minute. Because of slip, the actual motor speed may be around 1,440 revolutions per minute. That means the motor naturally wants to run near one fixed speed. For many years, if industries wanted less flow from a pump or fan, they did not slow the motor. They used throttling valves, dampers, bypass lines, and mechanical methods. The motor kept running near full speed. The process output was reduced artificially. Energy was wasted. Then power electronics changed everything. With the development of semiconductor devices like diodes, thyristors, transistors, IGBTs, and microprocessor-based control systems, engineers could convert fixed-frequency AC supply into variable-frequency output. That was the birth of the modern VFD. Part 2. What exactly is a VFD? A variable-frequency drive is an electronic device that controls the speed of an AC motor by changing the frequency and voltage supplied to the motor. The U.S. Department of Energy describes a variable frequency drive as the most common type of adjustable speed drive, used to control motor speed by adjusting both frequency and voltage supplied to an AC motor. In simple words, a VFD takes fixed electrical power from the supply and gives the motor a controlled electrical output. Input may be 415 volts, 3-phase, 50 Hz. Output may be 415 volts, 3-phase, 50 Hz for full speed, 300 volts, 3-phase 35 Hz for lower speed, 200 volts, 3-phase 25 Hz for still lower speed. By reducing frequency, the VFD reduces motor speed. By increasing frequency, it increases motor speed, within the safe design limit of the motor and machine. So the VFD acts like a smart electronic gearbox, but without gears.